We are on number 127 from your semester exam study guide. All right. It's been a while since we've gone over sequences in series, okay? These are the formulas, and these formulas will be given to you on the test. This is an arithmetic, okay? This is a geometric sequence. Oh, sorry. Thank you. Arithmetic sequence, geometric sequence, okay? This is an arithmetic series. This is a geometric series. And this is an infinite geometric. Or I guess infinite geometric series. Yes, ma'am. Okay, you need to know that. Are there any questions there? Yes. IG is infinite geometric. Okay, remember it is arithmetic if it has a common difference. That means we're either adding or subtracting the same number to get the next term, right? Like for example, on number 127, is this arithmetic, geometric, or neither? Arithmetic, okay? And how do you know it's arithmetic? You're adding by 2 every time. Plus 2, plus 2, plus 2, plus 2, right? So that's arithmetic. And is there a common ratio or a common difference? So it's difference. And what is that common difference? 2. Now we need to write the formula. Since this is an arithmetic sequence, we're going to use the arithmetic sequence formula, which is a sub n is equal to a sub 1. A sub 1 is the first term, which is 3, plus n minus 1 times d, which is the common difference, and in this case, that's 2. Any questions on number 127? Please look at 128. Is this arithmetic, geometric, or neither? I heard a geometric and I heard a neither. What is it? I hear.
It goes.
Okay.
1 times 4, but then it is times 3.
Good. Times 4. But what is 16 times 4? Is it 48? No. So you need to check it all the way through, okay? So this is neither. Please look at number 129. Is this arithmetic, geometric, or neither?
Geometric.
Okay. Do you agree that it's geometric?
Geometric.
All right. Alvin is pretty confident it's geometric.
Yeah. Because
If it's geometric, then what would the common ratio be, Alvin?
2/3. Or
If it's 2/3, then it would be getting smaller, right?
3 halves.
3 halves. Perfect. Okay. It is geometric, and the ratio is 3 halves. Okay. Geometric means you're multiplying by something, right? But the thing you're multiplying by each time could be a fraction, right? So we have 8, and what is 8 times 3 halves?
8 times
Is
3
12, and 12 times 3 halves is 18, and 18 times 3 halves is 27. Now, the way we can work backwards from this is we need to pick a term, like 12, and the term before that. 12 divided by 8 is 3 halves, right? Which needs to be equal to 18 divided by 12. Is that also 3 halves?
Yeah.
And then what is 27 divided by 18? That's 3 halves. So you can see that they do have a common ratio, which makes this a geometric sequence. And the common ratio is 3 halves. Any questions here?
No, do we need to write the equation?
Yes, we need to write. You could, yeah. But the difference between 3 halves and when you write this as a decimal, oh, there's no difference because it's 1 1/2. It's cool. If it were 2/3, it would be an approximation, but 3 halves, you can write as decimal. Any question? Yes. A sub n? A sub n, it's saying the nth term. Let me explain that. So, okay. So our formula for number 129 would be a sub n is equal to the first term, which is 8, times r, which is 3 halves, to the power of n minus 1, okay? And guys, what n represents is n represents the term number of the sequence. So if you look right here, the first term is 8. So here, n is 1. So if I plug in 1 here for n, guess what I'm going to get? 8, right? Because 1 minus 1 is 0, 3 halves to the 0 is 1, and 1 times 8 is 8. If I plug in a 2 here, this is the second term. 12 is the second term. So when I plug in 2, what do I get? 12. When I plug in 4, what do I get? When I plug in 3, what do I get? Okay, on over here, Patricia, when I plug in 4, what do I get as my answer for 127?
Like you're adding 4?
No, if I plug 4 in this equation, don't do it, but you could just tell me. Okay, well, what n represents is the term number. So if 3 is the first term, when I plug in 1 for n, I'm going to get 3. 5 is the second term. When I plug 2 in, I get 5. So when I plug in 4, what should I get? Well, if this is 1, 2, 3, 4, that's the fourth term. So when I plug in 4, guess what I should get? 9. Let's check it out. 4 minus 1 is 3, and 3 times 2 is, and 6 plus 3 is 9. Is that cool? So do you kind of understand what we're doing here, guys? Okay. 130, I'll let you guys do that one on your own, but that should be arithmetic, right?
Yes, it should be.
Okay, now on 131, it's not asking us if it's arithmetic or geometric. It's telling us it's either one of those, so we know that it's not neither. So is this arithmetic or geometric? Arithmetic, okay, good. And what is the common difference? Or what? -9, is that right, guys? -9? Okay, so let's look at our formula, which is a sub n, but in this case, we're going to do a sub 101 is equal to a sub 1. What's our first term? -2 plus n. What is n? 101 minus 1 times d. And what is d? -9. So you're going to put that in your calculator, and I think you get like -902 or something. Is that what you guys got? Okay, good. Any questions about 131? All right, let's look at 133. On 133, is this arithmetic or geometric? Arithmetic, what are we adding each time? No, I'm sorry, I skipped 132. I'm sorry. But you're right, 132 would be arithmetic. I skipped it just because I felt like y'all did great with 131. So on 132, this is what? Geometric, very good. And we're going to use a new formula, this one, right? So that's a sub 10 is equal to our first term, which is 2. And then that's plus, that's not true at all. I was looking at the wrong formula, I'm sorry. A sub 10 is equal to our first term, which is 2, times our common ratio. What is our common ratio? 3. We're multiplying by 3 every time. So the 3 goes in the parentheses, and that's to the power of n. What is n? 10 minus 1, right? And you can put that in your calculator, and you get a big number. I want to say it's like 39. I don't know. I don't remember. I'm sorry. Please practice putting this in your calculator. It'll help you. 39,366. Is this what you guys got? And again, this was ratio, and the ratio was 3. Are there any questions here? Do you want to do 134 quickly? So this is a sub 8. Is this arithmetic or geometric?
Geometric.
Good. And the common ratio is what? 1/4? Okay, so this is a sub 8 is equal to our first term, which is 320, times our common ratio, which is 1/4, to the power of 8 minus 1. I would really, really like it if everybody practiced putting this in their calculator.
Okay, we'll do that.
Thank you, Alvin. Any questions? Did you guys get it? Okay, take your time.
I got,
It's okay. What'd you get, John Andrew?
73.
I didn't get 73.
Yeah, I don't think it's 73.
I got,
Yes, sir.
I got .02.
0.02, is that what you guys got? Okay, now let's talk about, let's say we were on our test, okay, and we got 73. Well, let's look and see what happens. We see that it's going down. It's getting smaller, right? So 73, it's sometimes we do something and we write our answer down and we don't think about it. If you have time, please go back and just sometimes think about the reasonableness of your answers. It happens all the time, okay? We make mistakes all the time. I make mistakes all the time. I did it right here, okay? So don't feel bad about making mistakes. I'm just letting you know how you could identify possible mistakes, okay? Are there any questions here? Okay, let's talk about another mistake that I made. Since we're on this topic, I forgot to put problems like these on your semester exam study guide. So it's just a few, they are going to be in your semester exam. So there's just a few that we're going to go over, but you do need to know how to do these, okay? You will be assessed on them on your semester exam. I forgot to, yes, sir. Yes, I'll put the answer key on Schoology, and if you'd like to come, or I'll see you tomorrow, I can make copies of this for you tomorrow, okay? Or I can make them today and you can get them tomorrow. So, I'm going to go back to our formula sheet. Do you see this? We've already done the arithmetic sequence and the geometric sequence. Now we need to talk about arithmetic and geometric series, okay? And what series are is they're just the sum of a sequence, okay? So it's just like we're adding all these numbers together and we get the sum, okay? Now, if there is a set endpoint, like a specific number of terms that we're finding the sum of, like 8 terms or 100 terms or 2,000 terms, as long as we know, then there will be a sum. However, if we don't know how many terms there are, then it's going to be an infinite geometric series, and we can use this to find the sum, okay? If our r is ever greater than 1, we won't have a sum at all, which just means that the numbers just keep on adding and adding and adding. They don't converge to a number. So let's look at an example like number 15. Look at 15 and 16. These are examples of arithmetic series, right? Well, if we have a base raised to a arithmetic, do you see the difference? Yes? Okay. So we're going to use the formula for an arithmetic series, which is S sub n is equal to n divided by 2 times a sub 1 plus a sub n. Now, n is a little tricky how we find n. And then you add 1. Good. So n is equal to the last term minus the first term, the last term number minus the first, plus 1. So that would be 100 minus 1 plus 1, which ends up just being 100 here. And I know what you're thinking, well, that was dumb. Why did we do that? We can just see it's 100. It's not always just the top number, okay? For example, on number 40, n is equal to 40 minus 0 plus 1, which is 41, right? I'm sorry, number 19. Thank you. Are there any questions? So let's plug this in. This is S, and n is 100, is equal to 100 divided by 2 times, now a sub 1 is the value for our first term, right? Now the term number is 1, so we plug in 1 here, and that gives us 2 times 1 plus 15, which is 17. So that's our a sub 1. Then we plug in 100 to find the value of the last term, so that's 2 times 100 plus 15, and that's going to give us 215, right? Okay, so then we're just going to simplify this. S sub 100 is equal to 50 times 232. And whatever 50 times 232 is our answer. So, are there any questions? Any questions? Did that seem, was that, yes, sir?
I was just wondering, you said we need to know this, but you forgot to give it to us, so, what can I do so I can practice?
I was going to make an extra sheet, and I can let you guys pick it up tomorrow. I'll also put it on Schoology. In addition to this video, I will also put the video up from the notes when we actually went over this in class.
Okay.
Is that cool?
Yeah.
All right. But what I don't want you to do is I don't want you to spend too much time on this one thing. Yes, I left off these few problems, but you know, remember this is a whole semester worth of material. Don't get caught up on just this one thing, okay? All right, number 24 is the same thing. We're not going to do 24. Number 17, is that arithmetic or geometric? Geometric, right? Number 18, arithmetic or geometric? Geometric, right? And number 19? Geometric, okay. Let's go ahead and do number 19. Number 19 gets a little ugly, so bear with me. We're going to use the formula for a geometric series, right, which is S sub n is equal to a sub 1 times 1 minus r to the n power divided by 1 minus r. Okay, and that's r to the n. That's n. So we already found that n was 41, right? So this is S sub 41 is equal to our first term. So our first term is what we get when we plug in 0 for n. So when we plug in 0, we get 3/5 to the 0 power, which is 1, and then 1 times 5 is, so that's 5 times 1 minus r, and our rate is 3/5, and that's to the n power, which is the 41st power, divided by 1 minus r, which is 3/5. Now, I know that's a lot of stuff, but if you put that in there with all of those parentheses, you can just throw that right into your calculator and it'll tell you your answer. Anybody want to go ahead and do that? Yes, ma'am. You plug 0 in for n. See right here it says n is equal to 0, right? Plug this in your calculator, go ahead.
I got 12.4, I got 12.5.
Is that what you guys got? That's what I got. Is that what y'all got? 12.5? Okay, so S sub, or this means like the sum of all the numbers from 0 to 40. When we plug in here, we will get a sum of 12.5. Any questions on number 19? Okay, number 20, this is an example of what? Do y'all remember this one? What is that? Infinite geometric, right? And the formula is S is equal to a sub 1 over 1 minus r. Yes, sir. Yeah. If you want to just leave it with me, you can. Yes, sir. Sure. Thank you, sir. All right, so a sub 1 is the first term, so what do we get when we plug in 0 for n? 1. So this is S is equal to 1 over 1 minus r, which is 1/10, our rate, or common ratio, I'm sorry. So then S is just equal to what? What would be 1 divided by 9/10? Right. So 10/9. Or you could put that in your calculator and get a decimal. Are there any questions? Okay, look at number 23. Is 23, when it's that dot to dot, is this infinite geometric? Is it geometric or is it arithmetic? Number 23. He says an arithmetic, right? An arithmetic series, correct? Do you understand why it's a series? On 25, what is that? It's actually it's an infinite geometric, yeah. Because the difference is we don't know how many terms, we don't know like when this is going to stop. And it actually doesn't, because it doesn't tell us. So it's infinite, but the thing is it's still converging because it's getting closer and closer to a number because it's getting smaller and smaller. Okay, so let's use our formula, which is the series, the sum is equal to a sub 1 divided by 1 minus r. So in this case, what's a sub 1? Good. And then what is r? Do we agree it's 1/3? And if we couldn't just see that, you remember you can take this term and divide it by the term in front of it, and 18 divided by 54 is equal to 1/3. So then that's 54 over 1 minus 1/3, which would be 54 divided by 2/3, which is equal to 54 times the reciprocal, which is 3/2, and that's going to be equal to 81. Is that correct? Half of 54 is 27, and 27 times 3 is 81. But it makes sense that this is 81, right?
It makes sense.
Well, the reason it makes sense is this is 54 and 6 and 18, right? 54 plus 6 is 60, and 60 plus 18 is 78, right?
Right.
Now, we're going to continue adding things, but the things we're adding are really small, right? And they just get smaller. So we have 78 at this point, and when we continue adding really, really small things, it's not going to get much bigger than 78. For example, 81, it's going to get really, really close to 81, but it's never actually going to get to 81.
Like it never actually touches, just like on our graph.
Right. Okay, any questions? Look at number 26. What do you guys think this is? Infinite geometric? No, it doesn't tell us a certain number of terms, so it has to be, right? Do you see that? Now, what is r here in number 26? 2. When we are using the formula for infinite geometric, we can't have a rate that's greater than 1 because it's not going to converge to anything. It's just going to keep on going. We're just going to continually add. It's never going to converge to, it's not going to have a sum. Yes, sir. Okay, the series is when we're adding up the terms of a sequence. So the series will have like plus signs, or this symbol, which means like the sigma, which means we're adding. This is a summation symbol. It's saying this reads the sum of all numbers from 1 to infinity when we plug in here. This is the sum of all numbers from 1 to 6. So it's like they plug in 1, and then they add that to 2, and then they add that to 3. What? So when you plug the ends in, it makes a sequence, and then when you add each term of the sequence together, that's what this is, a series. Which this is the same thing as this, okay?
Will you do 23?
Sure. Okay, 23, so this is a arithmetic geometric or infinite geometric. Arithmetic, okay, because we're going down by 2. We know the first term is 100. We know that n happens to be 102, but I want you to know that a sub 1 is 100 because that's the first term. What? Because it says the first 100 terms. So we're only adding 100 terms.
So 8 for 24 would be 8.
Yes. We're going to plug this into our arithmetic series, which is S sub n, or in this case, it's S sub 100, is equal to n divided by 2, or 100 divided by 2, times a sub 1, which is 100, plus a sub n, and a sub n is the last term. A sub n, first 100 terms. First term plus last term. What we would need to calculate here is we actually have to calculate a sub n. And we can find a sub n by using the sequence, which is a sub n, or a sub 100, is equal to the first term, which is 100, plus 100 minus 1 times d, which is our common difference, and that's negative 2. So go ahead and put that in your calculators. Did you get negative 98? So a sub n is negative 98, so I can replace this with negative 98. Okay, and then that's S sub 100, and that's 50 times 2, which is 100. There are a lot of hundreds flying around here. So does it make sense that it's 100? If you think about it, we go all the way this way, and it keeps on going down so that it gets to plus negative 96, right? And then plus negative 98. And if that's the last term, all of the ones in between cancel each other out. The negative 98, positive 98, negative 96, positive 96. So we're just left with that first term. I know it's a lot. It's a lot to take in. Because of, we start with it's just kind of the way it works out. If we start with 100, and we continue going down by 2, if this is our last term, this negative 98, it would have to take that 101 to get back there. Does that make sense? Okay, so okay. All right, so there's still more arithmetic and geometric series and sequences stuff we need to go over from your semester exam study guide. Now, this is, you guys kind of hate this. This is systems. We're going to have to set up a system. So I'm going to go over this as quickly as possible so that maybe we can get to something else today. We are going to have to set up a equation here using our a sub n is equal to a sub 1 plus n minus 1 times d. Excuse me. So I'm going to use this first. A sub n is 41, and that's equal to a sub 1, which is the first term. We do not know that. We do know that n is 10 in this example, and then we don't know what d is. And we can just simplify this to be 41 is equal to a sub 1 plus 9d. Now we're going to do the same thing with this guy over here. That's 61 is equal to a sub 1, which we don't know. We do know that n is 15 in this example, so that's 15 minus 1. And we, again, don't know what d is. So we can simplify this as 61 equals a sub 1 plus 14d. Do you see now that we have this system of equations? We have two variables, two equations with two unknowns, but we can cancel out one of those unknowns, so we have one equation with one unknown. So what we're going to do now is we are going to multiply this by negative 1, so all of these signs change, and we're just going to add down. That gives us negative 20 is equal to, the a's canceled out. That's what we knew was going to happen, and that's why we did that. And then this is negative 5d. When we divide both sides by negative 5, we get d is equal to 4. So the common difference is 4. Any questions? Now that we know that our common difference is 4, we can plug that in to one of these original equations. So this is going to be, I'm picking the first one, but you could pick this one. 41 is equal to a sub 1 plus 9 times 4. And that gives us 41 equals a sub 1 plus 36. subtract 36, and we get a sub 1 is equal to 5, which means the first term in the sequence is 5. Now, we still are not done yet. We have to actually find a sub 3, but we can easily find a sub 3 now that we have a sub 1 and d. A sub 3 is equal to the first term, which in this sequence is 5, plus n, which is 3 minus 1 times d, which we found to be 4. That gave us a sub 3 is equal to 5 plus 2 times 4 is 8, and so a sub 3 is equal to 13. Sorry. Any questions there? That was fun, right? Please remember that this is just a small part of this whole semester exam, okay? So don't panic too much. All right, do y'all need a second to write that down? Okay. All right. You guys ready? Okay, so we could do this 136 the same way, but kids really struggle with solving systems with geometric sequences. What I encourage you guys to do is to look at this this way. Remember, these little numbers represent the term. So this would be the third term, and what is the third term of this sequence? Negative 12, okay? Then what you do with the negative 12 is you multiply it by something, right? Let's call that r. And you get this. And then you multiply this by something, r again, and you get this. The fifth term. You multiply by r again, and then that gives you the sixth term. Do we know what the sixth term is? 96. So we have just created a little equation, and that is that negative 12 times r to the third power is equal to 96. Do you see how I did that? Yes? We would divide both sides by negative 12, and we get r cubed equals 8, negative 8. Okay, and then we take the cubed root of both sides, and we get that r is equal to negative 2. Okay? So that means that we're multiplying by negative 2. What that means is negative 12 times negative 2 times negative 2 times negative 2 is equal to 96, right? Now, if we're looking for this term, all we have to do is 96 times r times r times r, right? But what is r? Negative 2, right. So could you tell me what the ninth term is? So, negative 768? Yes? Okay. You did say 68, correct? Any questions there? Okay. Raise your hand if you have a question about any other problems. Any questions from your homework from last night or on any other problems? Yes, Griffin. 64. Okay, on 64, what I would do on 64 is I would wait to try to simplify. I'm just going to rewrite this as 3xz over 6y cubed. Is that cool? So now I'm going to multiply across, and that gives us 6x squared yz squared divided by 6x squared y cubed z squared. This is where x cannot be equal to 0, y cannot be equal to 0, and z cannot be equal to 0. 6's simplify, cancel, these cancel. We have 1y and 3y, so there's 2, and that becomes a 1. So our answer is 1 over y squared, when, of course, those are our restrictions. Does that help, Griffin? All right, other questions? Ma'am? Please remember that we're not packing up yet, we still have time, but this semester exam is 20% of your final grade, so if you have a question, please let me know. $71? Yeah. All right, 71. We're missing an x plus 3 and an x minus 3 here. Over here, we're just missing an x plus 3. We know that this factors to x plus 3 times x minus 3. I know I'm writing a lot. Are you understanding what I'm doing right now, Griffin? So we end up getting x plus 3 times x minus 3 over x plus 3 times x minus 3 plus 3 times x plus 3 over x plus 3 times x minus 3 equals 4 over x plus 3 times x minus 3. Okay, and what can we do with all of these denominators? Right. So then we get x squared plus, if we do this x squared minus 3x plus 3x, they cancel, right? So it's just x squared minus 9 plus 3x plus 9 equals 4. That becomes x squared plus 3x equals 4. X squared plus 3x minus 4 is equal to 0. I don't understand the question. Yeah. Uh-huh. Well, the only reason if we did not multiply this by x plus 3, x minus 3, then we would not be able to add the 1 and the 3 because they wouldn't have a common denominator. Does that make sense? All right, now you would factor and solve. So your two factors would be x minus 3, wait, multiplies to equal 4. It would be x plus 4 times x minus 1. So then your answer would be x equals negative 4 and x equals positive 1. And you'd plug those answers in to check for extraneous solutions. But I'm fairly certain you won't find any, which means that those are both solutions to this equation. Are there any questions there? Okay, I would like for you guys to continue just to work through your study guide. Try to get through some of the trig. Definitely get through all of the arithmetic and geometric sequences and series. And please be prepared to ask questions in class tomorrow.